Hey mathematicians, it's Justin again, and wow, what a journey it's been training for the triathlon. In fact, I had so much fun tracking my progress and analyzing data that I'm doing it all over again, this time as a coach. I'm helping new triathletes get race ready by designing workouts, supporting their training, and choosing the best gear. Today, we're using all the skills we've built this unit, from choosing the right metric units to converting between them and analyzing graphs to make informed decisions for our athletes. We'll build on the training guide we started in the last lesson to help our team train smarter, not harder. By the end of today's lesson, you'll be able to choose the right metric units for length, volume, and mass, convert between metric units using patterns, multiplication, and division, and represent and analyze data using graphs and charts to coach our team to the finish line. Have your guided notes ready, and let's help our athletes train their best. First things first, we need to map out the training for the run portion of the triathlon. Our athletes need to build endurance and improve their pacing, so their plan includes long distance days and lighter training days, all on a standard 400-meter track. On long training days, each athlete runs 4 kilometers, but the track is marked in meters. Remember that the prefix kilo means 1,000. So what is 4 kilometers in meters? Pause here to convert. One kilometer equals 1,000 meters, so 4 times 1,000 equals 4,000 meters. If one lap around the track is 400 meters, how many laps do athletes need to run to meet the total distance of 4,000 meters or 4 kilometers? 400 times 10 is 4,000, which means on long running days, athletes need to complete 10 full laps around the track. On light training days, runners cover a shorter distance. They run 2,400 meters. How would we write that using kilometers and meters as a mixed unit? Pause here to convert. 2,000 meters equals 2 kilometers, and the extra 400 meters stays as meters. So the distance as a mixed unit is 2 kilometers and 400 meters. To improve pacing, each athlete has a lap time goal for their 400-meter runs. Here's the lap time data for 1 week. Using this data, build a single-line graph that shows how lap times change throughout the week. What should we put on the x-axis? Yep, the days of the week. And on the y-axis? Yeah, the lap time goes on the vertical axis. Pause here to graph the data in your guided notes. Does your graph match mine? Great. What's the range of lap times across the week? Which day has the fastest time goal? Which days are recovery days, and how do you know? Pause here and record what you notice about the lap time patterns in your guided notes. The lap time range is 2 minutes. That's the difference between the fastest time, 1.5 minutes, and the slowest, 3.5 minutes. The fastest lap goal happens on Wednesday. The recovery days are Thursday and Sunday because the lap times are much slower at 3.5 minutes, helping athletes stay active without overtraining. Now we're using data just like a coach. But preparing for a triathlon means training for 3 sports, not just 1. A rest day from running might mean hopping on a bike or jumping into the pool instead. This bar graph shows the training distances for swimming, biking, and running over an 8-week period. First, what's the scale of this graph? The vertical y-axis is labeled in meters, and the intervals increase by 2,000. Choose swimming, biking, or running, then pause here to determine the range. What's the difference between the highest and lowest distance for that sport? Then find the mode, or the most frequently occurring distance. Finally, convert the total distance in meters trained over all 8 weeks to kilometers. Record all your thinking in your guided notes. I'll show you my work with biking. Starting with the range, the highest biking distance is 14,000 meters, and the lowest is 5,000 meters. 14,000 minus 5,000 equals a range of 9,000 meters. Now for the mode. The distance 8,000 meters shows up 3 times, the only repeating distance, so the mode for biking is 8,000 meters. And if we add up all 8 weeks of biking distances, we get a total of 71,000 meters. To convert that to kilometers, divide by 1,000. 71,000 divided by 1,000 equals 71 kilometers of biking across 8 weeks. Now that you've analyzed the training distances, what's one conclusion you can make about how this plan is structured? Which week is likely a recovery week, and how can you tell? Pause here to record your ideas in your guided notes. You might have noticed that balance is important to avoid overtraining. Since all 3 sports had lower training distances in week 7, we can interpret this as a recovery week and build this type of recovery week into our training guide. Now that we've analyzed distance, we can move on to hydration and equipment. Each athlete needs to drink 2 liters and 500 milliliters of water during a long training day. Pause here to convert this amount to milliliters only. We know that 1 liter equals 1,000 milliliters, so 2 liters equals 2,000 milliliters. And 2,000 plus 500 equals 2,500 total milliliters of drinking water per day. Finally, let's check the mass of some essential equipment. Each athlete carries a small gear pack with a helmet, shoes, and a water bottle. The helmet has a mass of 800 grams, the shoes have a mass of 1 kilogram and 200 grams, and the water bottle's mass is 450,000 milligrams. The gear pack itself has a mass of 3 kilograms. Pause here to convert each mass to grams and find the total mass of the pack and all the gear. Here's the mass of each item converted to grams. When we add them all together, we get 5,450 grams. That's the total mass each athlete carries during the race. Great job applying what you know about converting between larger and smaller metric units to make this information easier to understand and more useful for coaching. So, what have we learned today, besides the fact that it feels pretty great to be prepared for real-life measurement challenges? Well, now you know how to convert between metric units of length, volume, and mass using patterns, multiplication, and division, and analyze data using different types of graphs to make smart real-world decisions. Be sure to complete the practice questions and extension activities that go with this lesson to practice working with metric conversions, analyzing, and representing data. This is our Working with Measurements wrap-up lesson, which means the practice levels will review everything we've learned throughout lessons 6, 7, 8, and 9 of Unit 8. There is an extension activity to help you reflect on your progress and decide if there are any lessons you'd like to revisit before the unit assessment. You can review any of the lessons at any time because in math, as in life, every effort adds to your success. I'll see you next time. Hey.